In this video, we're going to discuss the midpoint formula. Now, the formula is right here, but let's not get into that just yet. Let's discuss just basically what it does. If you just took a quick sketch of the Cartesian plane and you put a couple of points on the plane, maybe one here, and you connected them with a segment like such. Where is the middle? Well, I think we could guess by eye that maybe the middle is somewhere around this spot right here. What the midpoint formula does is algebraically allow us to actually calculate those values using coordinates. Now, if you'll notice, you have an x sub 1, an x sub 2, and an x sub m. The x sub m is the coordinate of the midpoint. x1 and x2 are the x-coordinates of the other two endpoints. As always, a work-through example will help us make sense of everything. So let's go step by step. First, we have to identify the coordinates of this point here and this point here. So take a moment, press pause, and write the coordinates in coordinate form for those two endpoints. And when I ask you to press pause in videos, you should really press pause. Think it through yourself. Now, as you'll see, I've labeled my points on my graph A and B respectively. And it doesn't really matter what two letters you name it. And I just wanted to do that so that I can keep track of who's who over here. So A looks like it's at negative 5, 5, and B looks like it's at negative 1, negative 1. Now what we want to do is we want to label these like you've learned in Algebra 1, x sub 1, y sub 1, x sub 2, y sub 2, like such. Now that we have our coordinates labeled, we notice that what we're looking for is the actual coordinates of the midpoint. Now, if I were to guess just by eye, it looks like the midpoint is right about there, which looks to me like it's at negative 3, negative 3. I think that's a pretty good guess, but let's go ahead and process this algebraically and show how the formula actually works. So as you'll notice, I've filled in the work and kind of worked my way through it already. I've taken negative 5 and I've added it to negative 1. And why did I do that? Because here in the formula it says that x sub 1 plus x sub 2. And in my work, I labeled up here x sub 1 was negative 5, x sub 2 was negative 1. So I add those two together because that's what the formula calls for. I divide that by 2, always. I'm finding the average of the two endpoints. And that's going to equal my x sub m, m meaning the x-coordinates midpoint. Negative 5 plus negative 1 is negative 6. When I add two negatives together, I get a bigger negative. And half of negative 6 is negative 3, which is our x-coordinate of our midpoint. Now, we already said before by eye that, hey, we think that the x-coordinate for x sub m was negative 3. Now we know for sure that that's the case. Now let's go ahead, press pause, you follow through on the y's, then come back and check. And you should get the same results. They're same coordinates over here, following the same formula for the y values. I'm going to add up y sub 1 plus y sub 2 divided by 2. Negative 5 again plus negative 1 is still negative 6 divided by 2 is still negative 3. So our y sub m matches what we originally thought up here. So what we saw by eye, a rough sketch, matches what we're seeing algebraically. And that's where math teachers say, hey, make sure your answer makes sense. Graphically, it looks like it was about there, and algebraically, we're getting the same results, so seems to be that's the right answer. Let's move on. Different version. This next example, we're basically doing the same thing. We're looking for the midpoint of the line segment with the given endpoints. I see that I have two sets of coordinates. They're always going to give you two sets of coordinates. But who do the two sets represent? In this particular case, they are endpoints. So I'm still dealing with the x sub 1, y sub 1 as given, and I'm looking for the x sub m. At this point, you may want to press pause and sort of catch up with some of the notation that I've thrown in here. Now, what's important is I said we're basically doing the same thing, but what's different? They only gave us coordinates. They didn't give us the graph. So what I've done is I've just drawn a quick sketch graph, a little bit more to the left because I'm going 6 over. I'm only going 2 over this way. I put my endpoints right here. And then all I want to do at this point is just kind of ballpark. Where is the middle point? I don't know, maybe somewhere around there. Now what do I see? I don't know, it looks like I'm about 2 to the left and not quite even down to 1, because this is -1 right here, and I'm not even down that far. So looks like we're going to bump into some, fractions. And that's part of mathematics, and we'll deal with it today. So go ahead, press pause, label up your coordinates like I have mine labeled, put your graph in, then take a step while you're paused and try to do the algebra for the x sub 1 and x sub 2 first. Now, did you arrive at a -2 like I did? Well, let's go back and see what happened. My x sub 1 is 2, so I put 2 in where x sub 1 is in the formula. I add that, because that's what I do in the formula, to x sub 2 of -6. That's who my x sub 2 was if I labeled correctly. Now the rest of this, right, is a static piece of the formula. It's always going to be divided by -2 equals the x sub m, which is the x coordinate of my midpoint. That's what I'm looking for. Because I have endpoints, I must be looking for my midpoint. I process the algebra down. I get a -2 for x sub m, which was roughly what we saw in our sketch. And that's why I like the sketch, because these two things will help me feel confident about my answer. Now, let's just go ahead and zip through the y's. And what you should get is the same as me, a final answer of -2, -1/2 for our midpoint coordinate. And that looks to be in line with our picture right here. So, we have the given a picture, let's identify the coordinates and find the given midpoint. Then, without a picture, we give you the coordinates, you draw the picture, and process. So either way, we need to know those endpoints and we need to have a picture. What happens when we're only given one endpoint and a midpoint? Let's see how that works. So let's take a look at what we have here. This one, we're going to find the other endpoint, and that's where the big change comes in. Find the other endpoint of the line segment with the given endpoint and midpoint. So what we've been given this time is different. We've been given an endpoint and we've been given a midpoint. But it's the same midpoint formula, right? Look, folks, we have 3 components to each side of this formula. X sub 1 is our first component, x sub 2, and x sub m. 1, 2, 3 components. We give you 2 of the x's, you give us the third one. It doesn't matter to us, really, which 2 we give you. All it does is change the order in which we do the algebra. So we just got to pay close attention to the algebra. And again, close attention to labeling these points. Labeling in a graph is going to be what saves you. So now let's take care of that. Why don't you press pause and see if you can label. One of these is going to be x sub 1, y sub 1. The other one's going to be x sub m, y sub m. And who's who is just careful reading. Remember, your x sub 1, x sub 2s are endpoints. X sub m's and y sub m's are midpoints. Label, draw a sketch, press pause. All right, so we're going to move along quickly, but you can always rewatch this or scroll back and rewatch portions. Up here, what we have is our endpoint. So I call that point A. I labeled that point A in my picture. Note the scale is drawn to 2 because we're going to some big numbers on the other endpoint here. And our midpoint is at 4, 8. So that's 2, 4, and 2, 4, 6, 8. That's right here. I labeled that M for midpoint. So I'm going to label these coordinates as x sub n, y sub m. And I'm going to label these coordinates as x sub 1, y sub 1. So over here, you'll see I have labeled A is at -6, 4. B is, I don't know yet. That's what we're looking for. We're looking for the other endpoint. And M is 4, 8. Now it's the algebra that's about to be different here. Before we get into the algebra, though, where is B? Where is that other coordinate? Well, I know that I have this section right here. This is from one endpoint to the midpoint. So we're starting here, traveling this way, and I land on the midpoint. So it looks like we're halfway. So if we just sort of copied that piece, it looks like B is going to land somewhere out over here. I'll sort of scribble over my formula there. Now it looks like B is, pretty far right and pretty high up. If we just count it, it looks like 2, 4, 6, 8, 10, 12. And over here, 2, 4, 6, 8, 10, 12, I don't know, 14-ish. So it looks like some big numbers here. So let's see how the algebra plays out and if that all comes together for us. First, I'm just going to lay out one step here. So what I have is negative 6y, because that's my x sub 1. And then I add that to who? My x sub 2, because that's what I'm supposed to do in the formula. Divide that all by 2, and I set that equal to 4, y4, because that's the midpoint x-coordinate. That's my x sub m. X sub m goes here no matter if it's an unknown or a known. You can't just always put the two values that you know over here. These values all have labels, and those labels are meaningful. And again, this is something that you should have brought with you from Algebra 1. It's not the first time you're seeing these labels. Now what are we going to do? We're going to cross multiply and solve. When you cross multiply, keep in mind that there's an implied set of parentheses up here, but we're just going to multiply that times 1 anyway, so that's just going to stay itself. The 2 is going to get multiplied by the 4, and will give us 8. So go ahead, press pause, and finish this out. You should have gotten a value of x equals 14. And like we said, it looks like we went about 7 units this way, and each unit counts for 2, so that's 14. I think you heard my clock in the background. We're time's up almost. I've set up the final solution, and you should just go ahead and follow along and check your math. But what we have here are the y values. And again, why did I choose 4 plus y? Because 4 is our y sub 1. Y is our y sub 2, the unknown what we're looking for. 8 is our y sub m, the coordinate for the midpoint y value. And again, always divide it by 2 on this side. Once we cross multiply, 1 times all of that is 4 plus y. And 2 times 8 is 16. You subtract 4 from both sides, and you get a y of 12. And again, does this point over here look like it's about 14 over and 12 up? Seems to be realistic with my rough sketch, and I think we're all done here. Now it's just a matter of practicing some of these on your own. So the final part of this video would be for you to work through these 3 examples. This first example looks like our first example in the video. The second one corresponds to the second, and so on and so forth. You'll notice that some of these answers are fractional. So if you want to write 2.5 as a final answer, you can. You can also write 5 halves or 2.5. Same here. This could be negative 7 halves or negative 3.5. That's up to you at this point. What's important and what we want to see is that you actually show in this that you've labeled these coordinates and identified who they are, A and B, so on and so forth, and shown all the algebra. With this example, we want to see a sketch and that you've labeled these coordinates and show all the algebra. With this one, again, a sketch and labels and show all the algebra. Once you're done, now you're really ready to start working on these on your own. Hope this was helpful.